Another draft physics video presentation. Still in that phase. So I'll do some comments, then some stuff on gravity, probably. Probably nothing new, just new ways of saying it, perhaps. Yeah. Hopefully, something to feed on. Sorry. Yeah, really not with the program. I just having such a hard time finding any incentive to. The world is so stupid. Anyway, you included, probably. So anyway, some guy, the PU actually has capacitors with a transformer. I don't know what the PU means. But anyway, so a minor point. So in the electric boom video, when he's lighting up the LEDs and pointing out how the inductor stores energy, the fact that the adapter has a capacitor in it is sort of irrelevant. The capacitor isn't for storing energy, it's just for evening out the gaps in the energy, so to speak, the pulses, from converting AC into DC. So it doesn't really have anything to do with the principles involved, that the coil of wire is where the energy is trapped. And so I think it's an important distinction. So the real point is that, you know, where in this coil is it possible for you to understand that energy can be stored in it? That is, the ability to move atoms, right? I mean, that's what electricity is moving some part of atoms anyway, making atoms like longer than they are round. So say they used to be round and now they're long, and even that you could understand as movement. You know, you're moving, the electrons are pushing them in a direction, and that pressure, you know, like there'd be higher pressure here than there is here, you know. You can see that, hopefully, you know, just about. So you're saying that once I turn the current off, so I stopped putting electricity through the inductor, so I have charged it in the sense that I've changed it by putting electricity through, forcing these atoms to do this pressurizing thing, this change in their shape. You know, the electrons are tighter together. Let's just say that's the principle. The electrons were like this, and now the electrons are like this in the wire when the electricity is going through. And so I stopped doing that. So now the electrons can repressurize, you could argue. But the catch is where is this stored energy? Because it's going to keep those things pressurized. It's going to keep a current coming out of this wire for some reason. For some reason, nothing's going in and something's going to come out. And the question is where's the something? What form is it in? So you could argue that it was in the form of this pressure, but that doesn't really work because, in a sense, you know they're going to re-expand. See, you have to understand that being far apart is weak, and being close together is strong pressure. So you kind of have to understand that it's inverse to what it looks like. So when it goes to this weaker state, that's not going to create current. It can only create current when it's going into the stronger state, when you're pushing, not when you're relaxing. It relaxes that way, so to speak. It pressurizes this way. So you can't create a current by relaxing them. So something has to keep them unrelaxed, to keep the differential here, okay, lower than the differential here, to keep the pressure gradient that's going to keep pushing electricity. And as I've pointed out, the obvious is that it's still, there's energy. When you pressurize the atoms, you created energy between the wires, reflecting back and forth inside the coil. So inside the coil, you've created energy that's bouncing back and forth, reflecting off the wires. And depending on how tightly wrapped these wires are, this is a pretty closed system. Now, the more loose it is, the more of it gets out, and it's not going to go into the wire again. So this is the stuff that, when you turn the current off, this stuff is still moving. And some of it takes this amount of time to get to the wire, hit it, and then for the wire to transfer the pressure all the way down the wire. And that's the little extra boost you get after you turn the current off. That's the boost. So this energy that's trapped inside, that's the energy that all comes out fairly quickly if you have if the coil is tightly wound, and it's a small diameter. You can imagine that can happen very fast. I mean, comes out very fast, and you can have a lot of it because it's coming out very fast. There can be a lot of these little arrows trapped in here, and now they're just all going to come out really fast, and they're going to create a pressure that's going to be even higher than the electricity was creating. So the electricity creates this blah 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 going on inside the wire, and when all that dissipates out, repressurizes the electrons, it's all going to come out at once, and so you get a higher voltage back than the voltage you were actually running in the current. So the current just charged the interior of the inductor. Right. Just a way of explaining, you have to explain in what form or in what state or in what place the energy is stored. And my argument is it's stored in the interaction between the force reflecting inside the coil and the atoms of the wire. Yeah, but your point is not useful just because you're indicating that a capacitor has something to do with the effect, and the point being made, it has nothing to do with capacitors and has everything to do with just the inductor, and the capacitor is kind of superfluous to the storage of the energy because the capacitor isn't a storage capacitor, it's just a leveling capacitor. So I'm going to remove the comment. Alright, this Joseph Pena guy is kind of a pain in the ass, turns out. How do you explain the diffraction? Okay, so he doesn't understand what diffraction is, so one can achieve by shining a laser on a single divider. Now, I don't know how you haven't understood. I mean, I made it just so damn clear in the videos. I already pointed out that Newton already did that experiment. The single impediment experiment was done by Newton. Okay, there's no doubt about that. The single hair. He did the experiment. All right, so, and it's not diffraction, okay, it's interference. So diffraction is this. Diffraction is just sending stuff like this. No pattern, just an even amount of stuff over a blob. So when you take something this size and you turn it up and you spread it, that's diffraction. Okay, interference is when specific places only, and then specific places only, and specific places only the light goes to. That's the interference pattern. That's the thing you need the two waves interfering with each other to create, is the interference. By your theory, of course. By the conventional theory, this is what you need. I've already explained that this is about recombining photons, that photons never interfere with each other in midair or any of that crap. They are broken and then reconstructed. So clearly the two things are different, and what you're arguing here, like I said, Newton did this single impediment. He got a interference pattern. He didn't get a diffraction pattern with a single impediment. He got diffraction, which you'll get, light did spread, okay, off these two surfaces in both ways. It spread around the corners and it spread off the edges, okay. So it diffracted, but it also created the pattern called Newton's rings. Well, with a single impediment, obviously it wasn't the rings, it was the bars. But he also did the single opening, which allows for rings to be created. I made that clear in the video. I don't know how you could. Why do I have to explain it again? You just don't want to watch the other videos, right? I mean, there's a playlist called Subjects. There's the newest video, find the newest one, and it has the best theory in it. But I already explained that you don't even understand what a photon is. So, you first have to understand what the hell's going in here. You think some kind of wave thing's going in here. Well, that's not what's happening. Photons are bits of energy, quanta, at a frequency. And the trick is their polarization means they're a little bit out of alignment. And the out of alignment, in fact, is thousands of atoms out of alignment. So it's a big out of alignment, relatively speaking. The out of alignment is as big as the wavelength, which isn't coincidental. It's simply because the electricity going through the atoms has a certain speed. You can get a certain distance in a certain amount of time, and that distance is going to be the same for creating both the frequency, and it's going to be there for creating how much the atoms will be separated in distance. So different atoms are creating, one atom's over here, one atom's over here, an atom's over here. Different atoms create the quanta, that is the photon. Different electrons on different atoms move, and that is what causes the photon. So the photon, first you have to understand what a photon is. And as I explained, when the photon's going through here, different pieces are knocked off. So some hit the impediment and break the photon. So now it doesn't have a frequency, right? It's lost its frequency. And you have to have, let's just say for the sake of argument, you have to have 6 of these things for them to be detected as a photon. That is, the ray length has to be 6Q, or you're not going to see it as a photon. So if I have 3Q, but I'm missing 4, and 5's okay. All right, so some get broken off, and then some just get knocked out of phase. Okay, they phase shift, and so this one is over here instead. So it has 2 over here. Okay, so that photon's also broken. And the key is all you're saying is you're going to break them in 2 different ways. So when they pass through the surface, they're hitting electrons. As they hit electrons, okay, they're being broken. And pieces of them, like one little bit will hit an electron here, one little bit over here will hit an electron over here. So those little pieces are getting shot in different places from different places. So they're not only going somewhere different, they're going somewhere different from different locations. And that's why this bar is a little bit fuzzy. It's because they're hitting electrons depending on the width of this. So the wider you make the slit, the more fuzzy you'll make the image, because the more irregularity in the distance from which they started to diverge. Also, the more likely it is you're going to crash some of them into the surface and get a reflection. But anyway, that's, don't even want to go into that. So anyway, so what you're doing is every time they hit an electron, every time one of these little bits, so one little bit hits an electron, not the whole photon. The whole photon can't hit an electron. The photon has a polarization that's 2,000 atoms high. Obviously, that can't hit a single electron. So each little bit hits a single electron. And each little bit doesn't care. There's no such thing as red and blue and green bits. Okay, the little bits aren't colored. They're all going the speed of light and have the same quantum mass, the same momentum. And when they hit an electron, a simple thing happens. A little bit hits an electron. The electron's under pressure, so it moves not straight because it's tied to other protons and it's repelling other electrons. So it can't move into another electron. It has to move sideways or some other way. And when it does that, it creates a new position in a new location. And you could say when it goes backwards, it releases the photon. It doesn't really matter how you explain the fact that there's a change in direction. It's just that we know this. This is Feynman diagram. This is very reliable science, that electrons convert photons and change the direction of the momentum. The photon is deflected, essentially. But it's not really deflected. It's being absorbed as momentum by the electron, and the electron moves into a location, and when it moves back, it releases the little bit, the little quanta, the little bit of energy. And so now the energy that was going this way is now going this way. And you can imagine if you hit 2 electrons, then you're going to go this way. And then if you hit 3 electrons, you might be ending up going that way. So the more electrons you hit, the further over you end up with. You end up being way over there, because you hit 4 or 5 or 6 or 7 and 10. The more you hit, the more deflected you get, potentially. I mean, you can deflect both ways, so it adds up. But anyway, and so all the pattern is the geometry of these little bits. So now you have all these little bits. Most of them survived. I mean, yes, some crashed into this wall and are dead, but most of them are still alive, and they're going in all kinds of different directions. But the directions have a formula based on the pressure of the electron. So the more pressure the electron's under, the change will be how tight these little bits are. So these bits will get tighter, closer and closer together. Okay, the more pressure the electrons are under. Less pressure, you get a wider spread. More pressure, you get a thinner spread, or vice versa. Doesn't matter. So anyway, each of these bits are now so these are just little bits going to these different places in space, and they're going to be regularized in the sense that you can't deflect any angle. It's not like you can deflect this way, you know, have infinite deflections. Remember, the idea is that when you hit an electron, you'll have a little bit of spread based on where you hit, the different position you hit the electron at, but there won't be that much spread. So you'll either go here, or, you know, a little bit off. You either go here when you hit 2 electrons, or a little bit off. You'll go here if you hit 3 electrons, or a little bit off, and 4. And so you get the idea. So there's specific locations where there's going to be a lot of the little bits going. Okay, so there'll be a lot of them going to these locations, generally speaking. And now the only question is what can you put together? What from these pieces? So you're getting pieces going from this side, going here, here, and straight, you could say, and then the same thing happening here. It goes straight, goes here, or it goes here, or it goes here. So you have bits going from all these different angles with some limitations on, it's not an infinite number of angles. But anyway, and so now you're just saying, okay, what's the geometry for putting them back together? What's the geometry from this location generally speaking, and this location generally speaking, when I take a bit that goes from this side and I take a bit from going from this side, when do I have the right wavelength change? This distance equals a wavelength, and if it equals the wavelength of blue, well then I'll remake a blue photon here. And if it's the wavelength of red, then I'll make a red one will be over here, because that has to have a bigger distance difference between the two lines. That's why I'll make red ones. So I'll make blue ones here, I'll make red ones here, you know, blah blah blah. And the same goes that's for hitting 2 electrons. But if you hit 4 electrons, well then there'll be another blue, you know, at the 4 mark, because it's twice this exact distance. And so it's really just the geometry of combining. So the redness and the blueness of the photons, the frequency, isn't destroyed by going past the slit, but each little bit is being treated. There's nothing here, there's nothing about this dimension that decided whether a blue photon was going to go here, 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 here. What's deciding it is the pressure of the electron. So how much deflection there actually was in every bit of the quanta. So all the quanta are treated as, this can't tell. When the electron is getting hit by a bit, it can't tell whether it was a red or a blue or a green quanta. Just doesn't matter. They all get treated the same, but the fact is they are different in the sense that their wavelengths are different, and so the distance, the geometry for their path length difference is very explicit. So you can't put 2 red ones back together, you know, 2 of the ones that were red. You can't recombine them, you know, by having 2 broken pieces, and one provides one provides. You could just make it simple and say, you know, they got broken, and so one of them's only 3 units, you know, of the right frequency, and the other one's 3 units, but they have this different phase. And so now you can connect these two. These two can hit, and they'll appear when they hit the surface as being one continuous photon. So you're just putting pieces of photons back together and turning them into whole ones again. I didn't intend to reiterate that, but I mean, I did it in the video. I mean, I've already explained this. I mean, to ask questions about why I don't explain something I've already explained really sucks. Okay, It's easy to set up this experiment, of course. Yeah, I've done it. I have video of it from different people doing it. Fuck you. Just place it in the middle of a laser beam. The conventional view would be that an interference pattern emerges. Exactly. It's a pattern. When you have the pattern, it's not just divergence. It's an interference pattern, meaning you have to, for their theory to work, you have to create two elements that interfere with each other. Shit. That's why they invent wave functions and all that horse shit. It's because they don't know what a photon is in the first place. Anyway. Would be that an interference pattern emerges because we can't determine which path information. So this is more just gibberish. There's no such thing as path information. Things actually go places, okay? When I roll dice at Las Vegas, no asshole ever goes, well, there's the path information as the dice bounces off the wall. There's no information. There's no path information doing anything. The dice are actually hitting physical objects and physically interacting with them. Path information is a horseshit terminology. I'm sorry you're so stupid to think that this is relevant. That's not even their explanation. Their explanation is that the damn frickin' photon is some kind of wavy-ton, and somehow it breaks into two wave functiony things, and somehow those two things interfere with each other in space and constructively and destructively interfere. When no, all that happens is you break the photon and you reconstruct a certain number of them. You break them and then you remake a certain number. There is no destructive interference. Can't determine which path information. Oh, it's such jargon. In this case, which side of the divider did the photon take? So their argument is if it took one side or the other, there wouldn't be any interference. So obviously it didn't take one path. Give that the difference patterns could be instantly destroyed merely by blocking one side of the divider. How do you block one side of a divider? Seriously. Yeah. It just doesn't make much sense, does it? I mean, it's just a surface then, a single surface. And a single surface is actually doing the same sort of thing. It's just that it can't remake photons as easily because it doesn't have two sources. So, he's saying block one side of the divider. Well, what is that? Oh, that just means that you've got a regular surface then. Right? You're just shooting things by a regular surface, a single surface. And yes, a single surface will cause photons, will interact with the electrons. They'll do the same thing, okay? But quite obviously, now your only path lengths to different locations is going to be limited by where you're hitting the electrons. So you have this distance, and you have this distance, and you have this distance. And those distances can have a wavelength difference or a phase difference that can allow you to create some pattern. But the pattern is so slight with single surfaces, it's really hard to, you have to use optics essentially to see the diffraction on single surfaces. But it's still there. It's just now you don't have two sources. You don't have another source of broken bits from over here, these extra broken bits to put photons back together. And without those, you're kind of out of luck, because all you can do is, see, when you have two surfaces, you can have two photons that were at the same phase and the same event and put two of those together. But when you only have one surface, it means the only thing you can work with is the distance difference between when they hit electrons, where they got deflected from. And that's the only difference you can use to put a pattern together with. So it's a much more limited ability to reconstruct the photons. Any break you do to them is a lot more permanent with a single slit. All right, anyway. Merely by blocking one side of the divider, is this not experimental proof that your theory is false? No, it's just absolute nonsense. I'm proving your theory is false by demonstrating that the single slit doesn't produce an interference pattern in water. Okay, and it should, by theory. Okay, and why does the single slit produce two waves And then when I have a double slit, the two slits only produce one wave each. So why does a single slit produce two waves when it's a single slit, but only produces one wave when it's a double slit? You know, one each. I mean, there's lots of reasons to say there's completely contradictions in your nonsense. The patterns don't match the math. The photon pattern is very different than the electron pattern. Blah, 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 blah. But again, your theory is broken. I mean, this theory that it's a wave, it doesn't make any sense. How does even wave theory work? You know, you block the slit. What does that mean? You're saying, okay, so if I open a single slit, you know, I'm trying to think of a way to say this. See, you're really depending on this idea of breaking something. Well, okay, so you're saying when I have an impediment and I have these two surfaces, which I'll argue is critical. Okay, I have two surfaces with an impediment, and then I have a single slit. So if I block this so it only has one surface, okay, the one surface experiment doesn't get me anywhere. But I would still argue to you, right? You know that these two sides are going to create your diffraction. Well, how are you doing it with a single slit? What's your hope of creating whatever these two waves are? Why do two waves pop out of the single slit? You don't have any theory that makes that sense. I mean, isn't that proof that your theory is wrong? In the sense that, why would this create two waves? I mean, you can understand where one wave's coming in, and the impediment's going to kill this whole middle part, so now you're going to have two waves coming out. Well, that's sort of understandable, how this breaks, how the single impediment breaks a wave in half. But how does a single slit break the wave into two pieces? How does that happen? I mean, what happens in water is clearly this. Okay, one wave comes out. One wave, no interference. I drop a pebble into the water. There's just one wave that goes out. It's not complicated. So you don't have any theory for this. You don't have any rational explanation for why two waves pop out of that. And then when I put those two slits in the double slit experiment, though, hey, only one wave's coming out of here. And only one wave's coming out of here. Why? That doesn't make any sense. So no, doesn't that prove your theory to be bullshit? Their theory, whatever. So anyway, this whole patronizing horseshit, get a clue. I've made 1,000 videos on this channel telling me I haven't done something or how do I account for. Well, if you're not going to bother doing the research, right? I mean, what? I should waste anybody's time explaining to you what's in the other videos? You know, I have to personally tutor you? Well, I'm not going to do that. Alright, so in Mendham, any chance you could produce a video where you explain the quantum eraser experiment? So it's another, I've done at least 3 videos on the subject at least. The whole experiment is a fantasy. Okay, so you're going to tell me I have to explain a fantasy experiment. So the underlying principle is the 3-filter principle, which we've already been over so many times. But this is all based on you think they understand what polarization film does, right? And that if I have these 2 filters crossing each other, so if I just have 2 filters going opposite ways, you could say, okay, you get 0 results out of this, because the polarized light here is destroyed going vertical, and this one destroys all the horizontals. Doesn't matter which way you think about it. If I have these 2 bars lined up on top of each other, you can see that I can't throw a frisbee anyway and get it in there, right? So if I'm throwing a frisbee, I got no chance. Both ways are blocked. You know, if it's this way, I got a chance to get frisbees this way. If the bars are this way, I can throw a frisbee lengthwise and get through the bars. But I can't get any frisbees through that. But somehow, when I put this 3rd filter in going this way, all of a sudden I get, 25% of my frickin' light back. Well, how did that work? How did I get it back? Your wave theory doesn't explain how you get it back. But my theory says, yeah, that makes perfectly good sense. Because all this is polarizing. This is 2x polarization, 1x polarization, 2x polarization. There's no blocking of photons. There's just changing their phase. You're just changing the phase of the photons. So this little bit, because it's out of alignment, right, it's polarized. it gets 2x phase shifted, and this is only 1x phase shifted, so that means this one is essentially had its phase jumped to here. So now instead of a photon being here, they got 2 of them here. And if I put it through another filter that rephase shifts this one to here, well, I'm back in business because now I have my frequency back. So all this is a phase shifter. They don't even know that. They don't know how polarizing film works. Their theory is crazy and convoluted and silly, and it has nothing to do with the fact that the filter never killed the photon. It merely broke the photons. It merely changed the phase of the certain pieces of the quanta. So the quanta's going through, and some bits of the quanta, yeah, you can see some of those, some bits are changed in their phase. This one changes here, this one goes over here, this one. So their phase is getting all messed up, and all you're doing is reconstructing again. So now by changing the phase with this filter, you've made some of the photons whole again, and now they can go through this way. You've changed the angle of the frisbee as it's going through, so to speak. But it really isn't. I don't want to say it's about angles. It's just about phase. All polarizing film does is change phase. It doesn't destroy any bits. It doesn't absorb any photons. It doesn't destroy any photons. It just puts them in a condition where you can't see them because they're out of phase. And you can put them back in phase. So the more filters I put in, ironically, right, if I go with 45 degrees, I can get 25% back. But if I put a 10 in, and a 20, and a 30, and a 40, and a 50, I'll get 38% back. And if I put 10 filters in between, I can get the number up to 40%. So I can increase the number I get back by putting more filters in to try to get my phase back. So anyway, more on the quantum array. So let's see what else to say about it. The very idea that they have some crystal that creates 2 entangled photons. You've never proved that the photons are in any way entangled, okay, with any kind of hard evidence. This is statistical evidence. You put them through polarizing films that you don't even understand, and then you say, well, 75% of the photons should end up here when I put this filter in. So you have some conclusion when you don't even have a science that understands how the polarizing film works in the first place. And then you had to say, oh, the results I got were 85%. Well, maybe that's because you don't understand exactly how the polarizing film works. Like I said, I made the simple frisbee argument. All right? If you go in with this assumption of 50-50, you're going to end up with wrong results. So in the simple example of throwing a frisbee through jail bars, right, you can make a bet with somebody that, oh yeah, it doesn't matter which one you choose. Throwing frisbees this way or throwing frisbees this way. So the point is that every frisbee that goes this way will get blocked by the bars, the jail bars. There's no way to get a frisbee going this way through any of the bars anyway. It can't happen. But if I throw frisbees this way, the trick is they don't all go through because some of them hit the bar. So it's not 50-50. So again, they're doing a statistical analysis based on their assumptions, which I can demonstrate to be silly from the start. I mean, just made up. Crystals that create entangled photons. The very idea of entanglement is not a truth. And that's all they have. They have to have a tiny reason to believe that every one of their stupid assumptions based on being able to catch and throw photons, which we already know they can't do. So I mean, there's no point. It's almost no point in talking to you people. You're so fucking deluded. All right. In your estimation, how it is that the interference pattern reestablishes once each path information is erased? So this whole idea of path information is just nonsense and baby talk. There's no such thing. So keep talking like a baby. This experiment uses photons to mark and erase which path information using polarizing film. Right, and something they completely don't understand. Do you understand that polarizing film is transparent, mostly? And that it's not bars, it's not jail bars, that the photons go through both lines. The lines are not lines. The lines are just thicknesses. There's double film and then one layer of film. Double film, one layer of film. And the second layer of film is just causing a phase shift, just like 3D movie glasses. The trick with 3D movie glasses is it's just too polarizing. One polarizer this way, one polarizer this way, and on one of the lenses, they just put another layer of clear plastic to create a phase shift. And that's it. They're not destroying anything. They're just shifting where the quantas are. And phase shift is critical to being able to see or not see a photon. Anyway, well, you people are just hopeless. I mean, the evidence for any of that quantum woo bullshit of entanglement or erasing or any of that crap is just, you just forget it. I mean, if you fall for that, you'll fall for anything. Because it's so far from hard proof. All right, erases which paths are using the film. I'm not clear at all about how your post-Newtonian view can account for this. So again, this slander that somehow all I know is Newton and I don't know any other experiment since Newton. That's not my argument. My argument is your capacity to do rational interpretation of evidence. That is, not to jump the evidence, not to be so fucking irresponsible. Newton plainly stated when he didn't know an answer. He posed no answer for Newton's rings. He's famous for their existence, and yet he speculated not on what was creating the pattern. He just explained, this is what it does. I don't know exactly how it's doing it. And he said the same thing about gravity, because he was a responsible scientist. He wasn't some asshole who jumps to bizarre conclusions because one very complex experiment full of assumptions comes up with a 10% difference in the outcome, and all of a sudden we have hysterically proven that photons have ESP. No, you haven't even come close to proving that. Oh, I just hate you fuckers. I mean, go ahead, be religious. I can't stop you. You think go look up a quantum eraser experiment and tell me how, yes, I fully understand what they're doing. I fully understand the crystal creating two entangled photons. I don't think you do. All right, it is interesting to say how you debunk and trash. Well, that's not really my point. There are theories. A theory is not only a theories until you can prove 100%. Well, that's not what you're doing. You're not trying to prove 100%. You're just trying to provide a more reasonable explanation. So somebody comes into court and says, look, I have the guy's fingerprints. We have some DNA. And we also have a videotape of him walking into the bank and holding a gun. And then the defense lawyer says, no, that's not what happened. The invisible man wore his clothes. Okay. No, the invisible man stole his DNA fingerprints and, stuck them there ahead of time. And even when and then he, you can make up, like, the invisible man can do anything. So he could have, altered the videotape. He could have done a million different things, to set the guy up and make him look like he's guilty. He could have moved his arms, or could have held the gun, in space in front of him or something. Who knows? I'm just saying. So all of this is a trial, and you're saying, well, does that make sense? Does that wacky theory of theirs of the invisible man does the invisible crap make any sense? Or does this more sensible, well, there's electrons on surfaces and electrons cause photons to deflect? Or do you want to believe that somehow photons are a wave, which doesn't make any fucking sense, and that somehow you can break the waves in two kind of functiony things that aren't really waves, and they can interfere with each other like the wave couldn't, because they have magical, wave function powers. And they can figure out calculus and blah, blah, blah. I mean, fuck you. You want to believe that shit? Go ahead and believe it. I can't stop you, but it's just, Well, anyway, this guy's not the same guy, so. Anyway, all events may have a cause, so this is the other asshole. But what about indeterministic causation? What about fairy godmothers? What do you want to say? There's no proof of any indeterministic causation. There's no evidence of anything that ever happened without a cause. So you just believe it exists. Well, go ahead and believe it, okay? They tell you that this empty space is burping, spontaneously burping uncaused particles. Go ahead and believe it. I can't stop you, but it's bullshit. It's made up. There's no evidence for it. Yeesh. Alright, correction. The Earth is not releasing all the energy and is nowhere near its thermal capacity. Where did I say it was near its thermal capacity? I mean, its thermal capacity is molten like the sun. Its thermal capacity is huge. The point is that it's at equilibrium with its environment. Oh, man, you're stupid. Okay. It is increasing at about 5.5% every year. Well, I'd say that's got to be a horseshit number. Where did you get that from? So again, people just spout this shit. 0.05% a year would mean, like, in 1,000 years, that would be, what, 5%? You think the Earth is getting hotter by 5% every 1,000 years? No, I don't think so. Or heavier, bigger. Where do you get that from, fuckhead? All right. It's also decreasing in total mass every year. So I don't even know what that means. It's increasing. So its thermal capacity is increasing by 5%, 0.05%, which is 5% every 1,000 years. But it's decreasing in total mass every year. And you prove that with what? Is lost. I mean, the fact that hydrogen helium is lost is so what? A lot of hydrogen helium is also injected by nuclei, cosmic rays, and all kinds of other energy sources. Then it received via meteors, which affects thermal capacity. It's decreasing. So again, you can say so. You say the only source of atoms mass to the Earth is meteors. Well, there are other sources, atomic sources. Atomic nuclei are mass. Okay. Eventually, sure, all energy goes somewhere, but until the battery is at saturation, it absolutely can get hotter. Well, again, I never said it couldn't get hotter. I said it's not going to get hotter unless you create another moon to stir up its guts, cause more gravity, more tension, more torsion, or the sun radiates more energy or something. I mean, the sun does such a superficial heating of just the surface that it's sort of irrelevant to the conversation. I mean, the real thermal circumstance is the one created by gravity, by the actual motion of the atoms in both directions. Okay. Being pushed by the universal force. Okay. I, for one, has realized I'm not getting any further in understanding these phenomenons. Well, I don't even know what that, I see something new every day, personally. But, okay, I'm sorry you don't get any of it. At least not without doing experiments of my own and deeper studies. Well, some of these experiments there's no practical way to do on your own. They're kind of complicated. You need instruments, and you got to be kind of careful, but stuff can blow up on you. Creating vacuums and such is not that simple. I need to see what's going on with my own eyes. Well, I don't know why that's at all necessary. There are people who do responsibly well-documented experiments. I'm saying there's few and far between, unfortunately. I mean, some of the best experiments I've seen were done in 1950, and it's kind of sad that nobody else is chronicling experiments as well as they did in the fucking 50s. With all our technology, they can't seem to do an honest demonstration of an experiment. I have some skills in programming which has taught me a certain mythology. Machine code was a mystery when I was younger. Machine code is really simple. It's just so dense. But I mean, the principle is so simple. It's just go to. If, then go to. I mean, there's only one function, essentially. If it's this, go here. Anyway, remember how fun it was to crack it. Like, what is this? Let's see. I might understand QM better if I put my mind into it, but I have other priorities. So what is this, your little personal story? It's very nice and not very useful. What I'm saying is, oh, you're actually saying something. Okay, I'll see. Is that you don't have to be a genius and nothing is impossible. Well, isn't that just all silver lining gooey bullshit? Nothing is impossible. That's horseshit right there, isn't it? If you really want it, isn't that just so special? So if you want to win the gold medal in every event in the Olympics, it's possible. You just have to want to. Except learning French. Whatever. Understanding French is much, much harder than QM. Whatever. I think there's worse languages in the universe. Those Chinese ones apparently aren't any fun at all. But such an incredibly useless comment. Alright, I saw a Crook's experiment video he did, and immediately he lost his credibility. Okay, so this is the silly fat man. Okay, so we won't bother. Ken Wheeler's horseshit experiments. Yes, they're all horseshit. Look at my bean seeds. It's totally proven. They totally differently, totally. I smell it. Real, I mean, just completely beautifully done controlled experiments. Sure looks shittier to me. Alright, what am I cleaning this for? I don't know. So I'll stop doing it. Yeah, on to the other bullshit. So anyway, this is some weird channel. I know it's called Freq Physics. Freq Physics? What the fuck would somebody call something a Freq? I don't know. They uploaded a ton of these videos. They don't have any. It's only, the whole channel's only got 23 subscribers. I think it's just stealing other people's videos and putting its little frecky F on it or something. I don't know. Very but they're kind of highly produced, you know, for just showing up. You know, the video has one view. You know, me. It's bizarre.
The origins of gravity. So you might be thinking to yourself,
I have it sped up a little.
Well, gravity is always studied. Physicists always think about it, and it's something that pretty much encapsulates all of us on the planet Earth.
Yeah, all this mush talk. No, we have a phenomenon. It's right in front of all of us, and we have this silly explanation for it. That somehow the space between, you know, my hand and this piece of chalk, there's some sort of bent space-time stuff that told the chalk it had to go that way. So something bent spacey thing says go down there. Yeah, that's the best they can do.
Also seems to dominate our whole universe, with things like keeping the planets in position, keeping the moons around the planet, keeping all the stars together.
Well, we know it doesn't really do that. It's just a phenomenon, and those things fall into the phenomenon. So, yes, obviously, any condition that exists, there'll be other conditions around it. Like if you have really bad BO, you might notice that, hey, people only get within 6 feet of me. And that'll be a phenomenon. But it won't be like you could tie the two things together in some kind of fundamental way. They're emergent facts. What is the essence of the thing itself? That's the question that needs answering.
And also our sun orbiting the Milky Way galaxy. There are also a lot more other things that gravity does that affects our everyday lives and the universe around us. But because of gravity, we don't just simply float off into space when we jump into the air, or objects.
So, yes, because there's this force, this phenomenon, and again, their silly explanation is that somehow the spent space, you know, you've violated it somehow by jumping up in the air, and it's going to push you back down with its non-existent application of non-force.
Objects simply just don't fall from the sky, unless they really want to. But it's great just understanding gravity, but where exactly does gravity come from?
So, more mush, right? It's great understanding gravity. No, understanding what happens is good. But it's really good to understand why it happens. And that's the question that is the vacuous, silly answer.
How do we really know about the origins of gravity? How does it start, and how strong can it really get? And how does it really work?
Yeah, so you won't get to any of that. Especially, I mean, this video is not going to answer any of those questions, which is, I mean, half the video is just going through the different planets and their different masses and densities. Just totally, who cares? He kind of, I mean, not, you know, it's not answering any of the important questions, just answering more of the, well, this is what happens, rather than why it happens.
So we are seemingly bound to the Earth's surface. This is due to an invisible force that we call gravity. To physicists, gravity is one of the most mysterious and unsolved things in the universe.
Except they have this stupid argument they make that we already resolved it. It's Einstein's bent space magic. So, I mean, how can it be both ways? How can it be a mystery and yet they have the answer? Oh, because nobody wants to say the answer is stupid.
Because we just don't have a true understanding of how it really works. Isaac Newton was pretty much a pioneer in understanding gravity. He created the laws of gravitation. He basically said that any two objects...
Again, he didn't create the laws, he discovered the laws. He discovered how it works. I mean, what the effect will be, and that it's a consistent effect. So it has fundamental function. And he defined the fundamental function. And it's related to the fact that the little bits, the little tiny nuclear bits, like logically you could sort of understand the atom, okay, and the little bits inside of it, well, they're the things that are actually affected by the force. They're the elemental bits are moved by gravity. Gravity affects little things. So anything that has mass, okay, will be affected by gravity, you know, and move. Shit.
in the universe exerted force of attraction on each other, and this is due to the relationship on the mass of the two objects and the distance between them. The greater the mass of the two objects and the shorter of the distance between them, they will exert a stronger gravitational force on each other. And this can be multiplied to have several objects, so it can get very complex very quickly.
Yes, and the gravity is constantly changing, which is the other thing to point out, that the amount of effect of gravity that something's causing is completely dependent on how far away from it you are. So like a light bulb, everything that is causing a gravitational change is causing it, okay, proportional to distance. So on the surface of the Earth it's 9.8. But a little above the surface of the Earth, it's 9.7, and then it's 9.6, and it gets weaker and weaker and weaker. So obviously, as things start moving towards each other, they start changing how much gravity effect they're having on each other, because more of their little gravitons are hitting each other. So yes, you have to do an integral. You have to have a system that can understand that when one thing moves, everything else is affected. And the other thing you have to also understand, again, that Newton didn't understand, and that even Einstein didn't understand, but he fell on it accidentally through his equations, is that the sun can look like it's just sitting here. But the truth is that its whole inside is a density. And more of its mass can be over here at any one minute. Its center of mass could be here, or its center of mass could be here. And those are different locations, okay? And the same is true for the big gaseous planets. They can look like it's right here. I'll say it's right here. But technically, its center of mass was over here, or it was over here. And so you saw it in one place, but its real location in terms of its gravitational mass, that is the amount of gravity it's creating, was in another place. So your numbers might be a little bit off because you can't see where the center of mass actually is.
A great example of this is our solar system. Not only do you have the sun, the moon, and the earth exerting gravity on each other, but you also have all the other planets, the moons, the comets, the asteroids, and all the other garbage that makes up the solar system. And this means that all these objects have an attraction to every other object.
Right, and it's not an attraction, so I guess that's the big punchline is, where does the energy come from? Why does this stuff move? And again, if you there's a thing called mock gravity, The idea has been around for 300 years, right? 300-year-old idea that they just don't pay any attention to because they think it's catastrophically broken as an idea. But the idea is there's energy going in all kinds of directions. And that for any object in this field of energy, that's going everywhere, any object is only going to be hit by things moving in a certain trajectory. And that if you count all those things, the universe looks like it's all heading right for me. So just like the opposite of the light bulb, I will be getting radiation from the universe in this manner, an even amount of pressure on all my surfaces heading in all directions, and that's from a random field. And everything is experiencing that. So when something else is in the field, what it's going to do is it's going to move based on the pressure. So if I eliminated this arrow, right, then there's going to be, in this one, then there's going to be less pressure in this direction. See, I'm getting hit by all these, but I'm not going to get hit in this direction, so I'm going to move in that direction. I'm going to be pushed. My little atoms, my electrons and protons, actually, are going to get hit by more stuff going this way than stuff going this way, and therefore I'm going to move that way. And when I move, that means I'm absorbing energy. So there's energy stuck inside of me when I'm moving, and now this thing isn't getting hit by extra. So it's getting all this, but it's not getting this contribution from my direction because I just absorbed it. And so now it's going to fall into the low pressure. And that's the real source of gravity. Now it's more complicated than this in the sense that every object that has every object that's a collection of electrons and protons is obviously creating a different way of storing that energy. So when you have a whole bunch of electrons and protons, what you do is each one of these little atoms is still doing the same thing. It's still moving towards the center. It's still trying to get somewhere, but it's stuck, on the surface. Can't get in because there's higher pressure inside than there is outside. And that pressure is moving in all directions. It's going this way, and it's going this way, and it's going this way. It's all randomized in there. And that's essentially swirling and doing all kinds of things. And so that's what's really creating the gravity, is the motion is in the interior of the Earth moving. So as the bits of the interior of the Earth move, those are absorbing the energy, and that's why you fall into it. So you fall into the movement towards me. So stuff moving towards me inside the Earth has absorbed energy to do that, and I'm falling into the low pressure. I'm being pushed.
Assuming that they all have mass, and these gravitational effects can change due to the distance and the mass of the object.
So again, they have to have this thing called mass. That is, they have to be matter. Matter is affected by gravity.
So then someone called Albert Einstein came along with his theory of relativity. He explained how gravity is more than just a force. It's kind of a curvature in the fabric of what we call space-time.
Right, and there's no point in playing this game. They can't do it honestly with this diagram. This diagram is two-dimensional mush. Doesn't mean anything. Doesn't explain anything mechanical, because we know the universe is three-dimensional. So this is useless. You can't bend things in 3 dimensions in every direction. There's no such way to do this. This bending idea is useless. So when it's taught, they actually teach it as like fluid pressure, water pressure. They teach it as a convergence from the outside in, a pressure, just like the pressure I described would be caused by random background radiation. Random background radiation will create exactly the same kind of convergence on every object, the same kind of even pressure on all its surfaces. So they don't teach this. They tell this as if it's an explanation, and it's just nonsense.
Where space and time are actually combined into one entity. This was an ingenious idea.
No, it's silly.
By Albert Einstein. The mass of an object can cause the space around it to bend and warp, depending on its mass.
So more silly images. I mean, they can't do it in 3 dimensions. They can't show you this warp in 3 dimensions. They can't do it any other way than to turn that into a light bulb with a bunch of arrows pointing right towards the middle. So again, they can only show it accurately as a convergence, as energy pointing right towards it. It's the only way they can do it honestly. This silly thing doesn't. What does that say to you? Well, there's one up here and one up here. That's three-dimensional. That's spherical gravity. No, it doesn't make any sense. This isn't spherical. This isn't even. It doesn't make any sense at all. It's a nonsensical visualization.
A great example of this is using a rubber sheet.
It's a terrible example because you have to roll things on the sheet and there's friction and all that kind of stuff. And again, it's just this. It's so disconnected. You know, obviously some things can look similar. You know, the Pomeranian dog can look like a fox. Does it mean they're the same animal? No.
Sitting a heavy ball in the center. This heavy ball will warp the rubber sheet. If we introduce smaller and lighter balls around the heavier one, we will see that they fall towards the heavier object because of the heavier ball's mass. But in reality, we can't see the curvature of space directly. We can only see it indirectly by the
You can't see it at all, so that's just silly. You can't see it indirectly. What you're seeing is exactly what would happen if I put a bunch of BBs in that field and I put two objects in it. They're getting hit by the BBs. The two objects will move towards each other proportional to the pressure created by the BBs. Because more BBs, there won't be any BBs in between the two objects.
Motions of the objects. This means that any object that gets too close to another heavier object will be affected because the space that it is moving through is curved towards the heavier object. Another thing that astronomers look at.
So more two-dimensional mush that totally doesn't illustrate the three-dimensional reality. If you gave me a description of photons like that, people wouldn't fall for it. People wouldn't fall for the explanation. Well, the light bulb is bending space, and each photon is on a different curve of space, and it's being bent by space. Nobody would believe that shit.
Is a phenomenon called gravitational lensing. This is basically when gravity has an effect on light.
Right, so a completely unproven effect. Just unproven. No experiments. The only thing that's ever bent light is scatter. Light hitting charged particles. That's the only way you bend a piece of light. That's the only way you change the direction a photon is going is by having it hit an electron. That's it. Or a proton.
A great example of this is a large galaxy or a cluster of galaxies.
No, it's a terrible example. It's ludicrous. It doesn't make any mathematical sense at all. It's just silly nonsense.
This can cause a straight beam of light to curve around these large objects, creating a lensed effect.
Yes. So, again, would make this isn't an actual image, so more fakery. And these things are never proportional, never spherically symmetrical. That makes absolutely no sense at all unless they invent some kind of dark extra gravity to create extra strong gravity in just the right places. Gravity creates the wrong shaped lens. It bends stuff more in the middle and bends stuff less, okay, the further away you go. The exact opposite of a magnifying lens. It has no hope of being a magnifying lens.
But looking at them even closer, you can see that the light actually curves.
Right, as if it was a magnifying lens when it's not. It's curving more on the outside than it curves on the inside. You get that? Can you see that in their drawing? Which is totally idiotic. The outside can't curve more. It curves much, much, much less because there's less gravity out there. So it's a complete contradiction of their own known facts of function. La 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 la. They didn't even say anything about what that piece of crap was.
But the most strangest thing about gravity is it's the weakest of the four fundamental forces.
No, that's not strange at all either when you think about what it is that's really causing it. So it's really just the same thing. The charged elements are sitting in the universe and they're doing two things, right? So this is so simple. It's just so simple. So if you just understand that there's rely on a little bit of color. So the little charge, the protons and the electrons, two different things. And the only difference is that when white stuff hits the white, when white cosmic background, so we just say blue and red light. right? So when red light, we'll call this red, just for the sake of argument, we'll call this blue. So this is red, and this is blue. Okay. Anyway, so when, for this white hits white, it just reflects. So everything coming in just gets reflected back out straight, so it's really nice and even and proportional. But when white hits the green thing, it diverts it, okay, perpendicularly. Now, that doesn't matter when nothing else is in the field, because it just ends up, stuff coming in this way ends up coming out that way and in this way, so it ends up doing the same exact thing. It'll look exactly the same. If there's no other charges in the field, it'll look just like this. But if the two charges mix with each other, that's when something quite bizarre happens between these two objects, where the white energy going this way ends up deflecting out this way, and any green energy going this way ends up deflecting out this way, and you end up with low pressure between them. And the opposite effect, when you put two electrons next to each other, you get this opposite problem where the reflections are perpetual. They never stop. And so the closer they get, the stronger the reflection gets, because you have more and more impacts. And with each impact, it's the same thing. This stuff's moving the speed of light, gets trapped in there, and it's an energy engine. I just bring this closer to this, and I create more energy, because I create more impacts. And that's the simple thing underlying it. Now, when this ends up being like a magnet, okay, this polarization effect. But if I take all those polarized elements and I put them at all random orientations, so I keep changing which way perpendicular is, if I randomize them, I neutralize all the difference, and I just end up with purple. So the big objects just make purple light. They never make blue or red light. And so that's why the force, they have no, zero, okay, charge energy potential. So that's why there's a huge difference between the force of charge and the force of gravity, because gravity is just going to measure movement. It's the radial force is irrelevant. The charge force is negated, and the only force left is the one where if I hit something, this is going the speed of light. It hits something. The speed of light is now not going out this side anymore, because this will move a little bit slow, right? So you can get the idea that I've converted something that was going the speed of light and getting somewhere into something going much slower than the speed of light, and therefore it's not going to get where it was going until this hits that. And then all of a sudden there's going to be a whole bunch of stored this, right? I hit this and hit this and hit this and hit this and hit this to move it. When it finally hits the other thing, it's going to be a big bang, because there's a ton of this stored inside of this moving. That's the simple principle.
Out of electromagnet, the strong nuclear force, and the weak nuclear force, the gravitational force is the weakest at the quantum level. There are also theories that state that gravity could also be a particle.
So again, the irony is that gravity is charge. It's the same energy that charge phenomenon is extracting. So a magnet is just showing you how strong gravity can be when you segregate the force. When you push all the blue stuff one way and all the red stuff another way, you can make the magnet incredibly powerful in terms of its effect on an electron. But it has no power if you neutralize that. If you dipole, then it looks like nothing to the electron, because it's pulling as much as it's pushing. So anyway, I think this is the end of the video, really, because the rest is just
some scientists have proposed
measuring
that
planets.
Particles called gravitons cause objects to be attracted.
Right, so the graviton is a silly idea from their perspective, because they're not making it an active momentum particle. They're making it the exact opposite. They're saying some kind of graviton hits the electron and tells the electron to move the other way. So it's not any kind of sensible momentum engine. It's not like the fist is here and you hit it and the fist moves slow. It's like the thing hits it and the fist goes this way. I mean, why would it do that? That's just nonsense.
To one another. This is just simply a theory, though. but it would explain.
Yes, it's a silly, again, just it's so silly in the sense that it's just completely backward to what we know. Momentum is always in a direction. You always have to conserve the momentum. So it's just silly to say you can do this to momentum. You really can't. You absorb and exchange. You can have an exchange of momentum, but you cannot possibly take momentum going this way and just unequalize it. There's always the equal opposite reaction. That's fundamental physics. A graviton would break fundamental conservation.
Explain why gravity is so weak at such a smaller level. Also, it could be a great idea into understanding new phenomena within our universe.
Yeah, it's like all these other things that could just be made up. Okay, your gluon, your boson, and your graviton, they're just magical particles with magical features. They just do what they want them to do, and they have no symptoms. They don't have any. They don't cause any side effects because, like dark matter, they're just constructions in their head. They're solving the problem by making something that just does the one thing they want and nothing else. Completely unrealistic.
That don't quite match our understanding of gravity. A great example of this is the center of black holes. Another idea that is vastly more popular and pretty much exists within our universe.
Yeah, so more nonsense, right? Just glosses over the fact that they got no evidence of any theoretical black hole like the real ones. You know,
are gravitational waves.
more mush for which there has been no evidence of any such thing ever being detected that's credible. It's not credible evidence.
These are generated when an object is accelerated by an external force.
No, it's not just accelerated by external force. No, they're accelerated by gravity, and they're converting their mass into some kind of new gravity. They're converting mass into gravity. That's the theory. So, you know, they're just lying. I mean, this is just such a silly diagram.
In the last couple of years, we've had some great observations of gravitational waves. And hopefully, within the future, we'll know a lot more about them.
Yes, you'll know in the future, they'll know that, wow, that was pretty silly that everybody fell for that crap.
And hopefully learn a lot more about how gravity really works.
Now, the more of them they build, the only good news is the more they put online, the fewer events they're detecting. So clearly, this is horseshit.
So our overall conclusion to gravity is that it works, but only when it's convenient to our mathematics. When you look at certain places in the universe, gravity simply breaks down. And this is very obvious when you look at the very small bits of the universe.
No, I'm afraid it doesn't, so there's no evidence of that either.
And the very large bits of the universe. These are the levels of atoms and molecules where gravity just stops working, and the very...
No, gravity is charge. It's still working. It's just obviously in the real form. You know, its native form. It's a polarized form, not in its neutralized form. Its dipole form, mixed dipoles, eliminates all the blue and the red, turns it all into purple.
big side of the universe, where we try to explain how galaxies keep themselves together and how the universe expands. There's something else out there that is stopping us from understanding gravity completely.
Well, no, what's stopping you from understanding is that you've accepted really wrong axioms, and you don't correct any mistakes ever made by physics. Again, positive and negative were wrongly assigned, and they have created convoluted mathematics based on that wrong assignment that ends up stating things that are just stupid. Current goes this way in a wire, the voltage goes this way. Stupid. Can't happen that way.
Like I said before, black holes and the moment of the Big Bang do not work with our current understanding of our mathematics of how gravity works.
Well, whatever. Our mathematics, which 80% of it could just be complete horseshit.
The problem is with physics is it seems to be in two parts, the astrophysics side and the particle physics side.
That's right. There's one universe. It's the tiny one. There's real empty space between protons and electrons. That's the real universe. That's the real empty space that we're in. The real space, the real universe is down there. It isn't here.
And we can't quite fit them together to create something that is an overall structure of what the universe really is. But scientists are really coming up with some great ideas, trying to put the fundamental forces into one to create one gigantic ultimate force of the universe.
Right, and they'll never get there because they've got two wrong starts. Quantum mechanics, woo mechanics, and woo bent space. They're both wrong answers. particles aren't waves. They aren't wavicles. There's no ether. There's active, real momentum moving in the universe in the form of photons, the elements of photons, the quanta. The quanta moves the speed of light, and it causes all the interactions between the heavier matter bits.
To be honest, that sounds rather familiar to a force that we all know and love. Our current
Right, some force you can manipulate by thinking about it.
understanding of the universe allows us to build upon of what we already know. Like I said before, we know what's wrong with the universe, but we don't know how to figure it out. But there are some great theories, some great experiments.
It's all great, yes, it's a great pile of mess that has gotten you wrong answers that you don't fix.
And some great minds really trying to tackle the problem of the origin.
Oh, just applaud all yourselves. And we're so spectacular and so great because we're selling this religion. That's all it is. Oh, God was a great guest. Jesus was even cooler as a guest. And the Holy Ghost, oh, that was such a special guest. Making that Holy Ghost thing, that's so interesting.
Of gravity. Gravity on other planets. So gravity is a very fundamental force in physics.
All right, so this is just absolutely useless because it's just, this is for grammar school kids or something. Telling us how big planets are and whatever. You already learned all that shit, right? Decades ago. All right, so I won't bother with that. Nice to know kind of stuff, but, you should know it already. But anyway, enough of a video. So, till the next time and such. And I will no doubt continue to endeavor to persevere until death. Speaking of which, my simulation guys are both missing in action. I guess they're coronavirus or something. I don't know. Very bizarre. But anyway, hopefully soon. We're right on the brink, and it's just, it's kind of disappointing. So, till the next time and such.